Summing up. A. The birth of modern atomic theory, from Lavoisier to Dalton. Lavoisier and the law of conservation of mass. In a chemical reaction, the mass of the reactants is exactly equal to the mass of the products. Proust and the law of definite proportions. A chemical compound always contains exactly the same proportion of elements by mass. Dalton and the law of multiple proportions. When an element combines with the same mass of a second element to form different compounds, the masses of the first element are ratios of small whole numbers. B. The atomic model of Dalton. Matter is made of tiny atoms which are indivisible and indestructible. All the atoms of the same element are identical and have the same mass. Atoms of an element cannot be converted into atoms of another element. Atoms of an element only combine with whole numbers of atoms of another element. Atoms cannot be created or destroyed, but are transferred whole from one compound to another. C. Atomic theory and the properties of matter. An atom is the smallest component of an element, possessing the chemical properties of the element. Elements are made of atoms that have identical chemical properties. Two or more atoms can bind together to form molecules that possess characteristic chemical properties. In addition to atoms and molecules, there are other particles called ions. These are atoms or groups of atoms that carry electric charges. D. Particles and energy. Kinetic molecular theory. The internal energy of a system is the sum of the kinetic and the potential energy. E system equals EK plus EP. The temperature of a body is proportional to the average kinetic energy of its constituent particles. Heating a system increases its internal energy. E. The phases of state as explained by the kinetic molecular theory. The melting and solidification of a pure substance occur at the same temperature. During melting and solidification, the temperature remains constant. The boiling and condensation of a pure substance occur at the same temperature. During boiling and condensation, the temperature remains constant. Melting and boiling are processes that involve an increase in the internal energy of a system. Solidification and condensation are processes that involve a decrease in the internal energy of a system. F. Latent heat. The latent heat of fusion is the amount of energy required to completely melt 1 gram of a substance at the melting temperature. It is an intensive property that is characteristic of each pure substance. The latent heat of fusion corresponds to the amount of energy needed to weaken the cohesive forces between the particles during the change of state. The latent heat of vaporization is the amount of energy required to completely evaporate 1 gram of a substance at the boiling point. It is an intensive property that is characteristic of each pure substance. For the same substance, the latent heat of vaporization is usually much greater than that of fusion.